Okay, we're going to do a little bit more here with completing the square. So just as a refresher, again, for a polynomial x squared plus bx, if you take the b and divide it by 2 and square it, that's the number you have to add on to get a perfect square trinomial, right? What's different about these examples here is that b, the coefficient in front of x, it's not necessarily a number that's divisible by 2, which makes the arithmetic a little bit more difficult, but not undoable. Okay, so let's take a look. This first example, we've got x squared minus x equal to 2. Okay, the leading coefficient in front of x squared is 1. That's good. And we have x squared minus x on one side of the equation and all the other stuff on the other. So this is a great way to start. So the first thing that I want to do is I want to take that b value. In this case, it's -1. Whether you take the negative with it, it doesn't make a difference because when you divide it by 2, you square it, and negative times a negative is a positive, so it doesn't really matter. But let's say we have a -1 value for b, right? If we divide that -1 by 2 and we square it, we get 1/4, right? So that's what we're going to add to both sides of the equation, right? What you add to one side, you got to add to the other. So we're adding 1/4 to both sides. Okay, now the question becomes, okay, well, how do you factor something like that? If you've got x squared minus x plus 1/4, remember the factoring number is the square root of what you added. And in our case, you can think about it as just b over 2, right? It's the initial step in the completing the square process. So in this case, we're going to have x minus 1/2, right? The square root of 1/4 is 1/2, quantity squared, equal to 2 plus 1/4. So we need to get a common denominator here. 8 over 4 is the same thing as 2, right? So we have 8 over 4 plus 1/4. So that would give us x minus 1/2 quantity squared equal to 9/4, right? When we add those fractions. So then we take the square root of both sides, okay, using the square root property, which means, let's see, the square root of 9/4 is going to be plus or minus 3/2, right? And then from there, we want to add 1/2 to both sides. X minus 1/2 plus 1/2 equal to 1/2 plus or minus 3/2. Okay, so that means I'm going to give myself plenty of room here so we can do a little of the arithmetic. We've got 1/2 plus 3/2, which is 4/2, which is 2, right? Or x is equal to 1/2 minus 3/2, which is equal to -2 over 2, which is equal to -1. Okay, so the solution set is -1, 2. Okay, so for this next example, we have x squared plus 5x plus 3 equal to 0. Okay, so I want the x squared plus 5x just on one side of the equation, so I'm going to subtract 3 from both sides. So I have x squared plus 5x plus 3 minus 3 equals to 0 minus 3. So that leaves x squared plus 5x equal to -3. Okay, so if I'm going to complete the square on that, the coefficient in front of x is 5, right? That's the b value. So I have 5 divided by 2 squared, which is equivalent to 25 over 4. So that's what I have to add to both sides of the equation. I'm going to have x squared plus 5x plus 25 over 4 equal to -3 plus 25 over 4. Now, remember when you go to factor this, it's a little scary with a fraction, but it need not be, because if you just take the square root of the number that you added, or the number that you squared over here, right, the b over 2, that's it, right? So we're going to have 5 over 2, and we're adding in the middle, so we're going to have x plus 5 over 2, quantity squared, equal to, let's get a common denominator here. So I'm going to have -12 over 4 plus 25 over 4 So that will be x plus 5 over 2 quantity squared equal to, let's see, negative 12 plus 25 is 13 over 4. All right, when we take the square root of both sides, we'll have x plus 5 halves equal to plus or minus the square root of 13 over the square root of 4, right? So you're taking the square root of 13 over 4, but that's equivalent to the square root of 13 over 2, right? Since the square root of 4 is 2. And then I'm going to subtract 5 halves from both sides. Okay, so I'm going to have x plus 5 halves minus 5 halves equal to negative 5 halves plus or minus square root 13 over 2. Okay, so x is equal to negative 5 plus or minus square root 13 all over 2, right? All right, so the solution set is going to be negative 5 minus square root 13 over 2, or negative 5 plus square root 13 over 2. Okay.